Hello, very good morning, my dear friends. Welcome back to the video lecture series. We are discussing the food analysis part, and in that we have completed the first 4 chapters. In the 5th chapter, we are discussing the characterizations of lipids. Okay, so in characterization of lipids, yesterday we have seen some methods such as iodine value, acid value, etc. Today our topic is how to determine peroxide value. What is meant by peroxide value? How to determine peroxide value for the lipid sample, for the fat sample. The principle of this procedure, principle of this method or peroxide value is that first of all we'll see what is the peroxide value. So peroxides are generally formed in the lipid sample, okay, lipid itself, and these peroxides are identified or determined by using these peroxides. It is called as lipid oxidation. So in this lipid oxidation process, these peroxides and hydroperoxides are formed, and they can be determined by detecting the peroxide value. So what is the definition? The milli equivalence of peroxide. Milli equivalence of peroxide required per kilogram of sample. Milli equivalence of peroxides per kilogram of sample. This is the definition of peroxide value of lipids. Okay. Now, how we are going to determine this peroxide value? The simple procedure is given. First of all, the sample is taken in acetic acid and isooctane solution. Acetic acid and isooctane solution is there, and in this solution, this sample is taken. Okay, and then in this acidic condition, the hydroperoxides reacts with potassium iodide. So the next step is addition of potassium iodide. Ki is added in this sample, lipid sample. So we have a lipid sample. In that we have taken acetic acid and isooctane, and again the potassium iodide is added. Okay. Then in this acidic condition, this reaction will be taken place. Okay, so ROH, that is alcohol, and KOH, that is potassium hydroxide, is formed, and this iodine is get liberated. This iodine is get liberated from this reaction. Then this iodine, liberated iodine, is then titrated. So this is a titrimetric analysis. It is just like a redox titration reaction, and this redox titrimetric analysis can be used to determine the peroxide value of the lipid sample. This liberated iodine is titrated against the sodium thiosulfate titrant, sodium thiosulfate Na2S2O3. Okay, and the indicator used is starch. We know that whenever there is a determination of iodine, the reagent or the indicator that we are using is starch indicator. First of all, in this case, when we have iodine sample, liberated iodine in our sample, and when we add a sodium thiosulfate and starch indicator, first of all we have a blue color solution, and as the titration is going on, we will pass the titrant through that solution. Then at that end point, this blue color starch solution is converted to colorless starch solution. Means the liberated iodine is get consumed by the sodium thiosulfate, and that is the end point of titration, where we get a colorless solution. Okay, so this reaction is going to happen there. So iodine is reacting with sodium thiosulfate, starch is indicator. This starch indicator is indicating the formation of the consumption of total iodine and the conversion of this iodine into sodium iodide. Okay, the sodium iodide will be formed, and sodium persulfate and starch will be remain as it is, but it is now in colorless. So the total blue color is get disappear. Okay, so this is the reactions and procedures that how to follow the procedure to determine the peroxide value. Then the peroxide value can be determined by using this equation: S minus B into N into 1000 divided by W. So what is S? S is nothing but volume of titrant in ml. Volume of titrant. This titrant is sodium thiosulfate. Volume of titrant required for blank solution, required for sample. Volume of titrant required for sample in milliliter ml. B is volume of titrant required for blank solution in ml. N is the normality. N is the normality of this sodium thiosulfate. Then 1000 is the conversion unit, okay, multiplying factor for gram to kilogram, and because this is milliequivalent and this is kilogram, so that's why multiplying factor is 1000 here, and divided by W. So W is the weight of that lipid sample. So in this way, this peroxide value in milliequivalent per kilogram of sample can be determined. Okay. Now the next value or the next analysis is nothing but para-anisidine value and Totox value. Para-anisidine value and Totox value. So what is this para-anisidine value? This value estimates the amount of alpha and beta unsaturated aldehydes. Alpha and beta unsaturated aldehydes which are formed during the lipid oxidation process. Actually, these alpha and beta unsaturated aldehydes are the secondary oxidation products of this lipid oxidation process, and these compounds, that is alpha and beta unsaturated aldehydes, can be determined from that fat sample by using para-anisidine. So what is the structure of para-anisidine? That we know. So it is anisole, and on the para position that is NH2 group is there. Okay, so that is called as para-anisidine, and this para-anisidine is then reacted, okay, is then treated with this alpha and beta unsaturated aldehydes, okay, and from that a chromogen, a colored compound known as chromogen is formed, and that chromogen is then estimated using spectrophotometrically. So spectrophotometric titration or spectrophotometric determination is used in the para-anisidine value determination. Okay, now the procedure is done, or determination is done by spectrophotometric determination that we have discussed here. Now what is this Totox value? This Totox value is the combination of, it is the sum of two values. These are peroxide value and para-anisidine value, and it can be calculated by using peroxide value plus double the value of para-anisidine value, double or 2 into para-anisidine value. So this equation gives you the total Totox value. Okay, this is known as Totox value. So this is the second estimation, that is now known as para-anisidine value and Totox value. Now the third method or third determination, our today's third determination is T-bars test or TBA test. T-bars test or TBA test stands for a name of the compound, okay, and that is nothing but thiobarbitoric acid reacting substances. Thiobarbitoric acid reacting substances. The T bar stands for thiobarbitoric acid. Thiobarbitoric acid reacting substances. Reacting substances test. This is the long form of this T-bars test. Thiobarbitoric acid reacting substances test. In short, it is also called as TBA test, that is thiobarbitoric acid test. Thiobarbitoric acid test. Okay. Now, what is the principle of this test? The principle of this test is very simple. This test is useful, or it is utilized, or it is used by the fat or lipid chemist or oil chemist to estimate the secondary oxidation products. We know that when lipid oxidation or auto oxidation of that lipids or fats kind of material or sample is going to happen, then different peroxides and hydroperoxides are formed. These are the primary oxidation products. Along with that, there is a secondary oxidation products formed, and these are determined by the different methods. So this is one of the p-anisidine value. It was also a determination of secondary oxidation products. In the same way, this T-bars and TBA test is also used for the determination or estimation of secondary oxidation products, and here particularly mainly we are determining melanoaldehyde. Okay, so melanoaldehyde is this is melanoaldehyde. Okay, so this is the secondary oxidation product, and such melanoaldehyde determination can be done by this TBA test. Okay, now what is this TBA test? This melanoaldehyde which is present in the our lipid sample as a secondary oxidation product of lipid oxidation is treated, which is present in our lipid sample, it is treated with a TBA. So what is this TBA? Thiobarbitoric acid. Thio means the sulfur atom is there, that's why it is called as thiobarbitoric acid. Okay, then by the reaction between them a colored product is formed, and that colored product is, we know that all colored products are spectrophotometrically active, or they are giving colors. Why they are giving colors? Because they are absorbing the radiations in the UV and visible spectrum of the electromagnetic radiation. So that's why these products are colored, and hence we can determine such substances by using spectrophotometric determination. Okay, now the process or procedure to follow this T-bars test or TBA test is, the sample is taken in a distilled water, highly pure deionized distilled water is then it is generally used. Okay, and it is taken in a distillation flask. So we know that what is the general assembly for the distillation assembly. Okay, we have a distillation flask, to that we connect the condenser. Okay, then that condenser is then having water condenser is having the inlet and outlet for the water supply, and then that condenser is having Liebig condenser again. Okay, it is having just like assembly. Okay, so this is the water condenser, and then this is a Liebig condenser. Okay, and we have a receiver here. Okay, so distillate can be received in this flask. We call it as a receiving flask. So this is the setup of our assembly. Okay, and in this round bottom flask or distillation flask, what we are taking here? We are taking a sample, lipid sample. Distilled water or deionized water is taken in this flask. Some distillating boiling beads or porcelain pieces are used here to avoid the bumping of this solution. Then some BHT, butylated hydroxytoluene, is then generally add. It is optional. If one can add, then it may add. Okay, butylated hydroxytoluene, and the pH is adjusted at the 1.2. pH is adjusted at the 1.2. So this is a very highly acidic pH. Okay, by adding a buffer solution, acidic buffer solution, you have to adjust the pH around 1.2. Okay, and all these contents is taken in distillation flask. Then heat that distillation flask so that distillation can occur. So before start of heating, the distillation flask is connected to the water condenser with a water supply. Okay, and then further arrangement is done in the similar way that we are going to do in a simple distillation process. Okay, so this is the receiver. Now distillation is done, and that distillate that we are recovering in the receiver is then treated. A sample of distillate, first 50 ml of that distillate is then taken and it is then treated with this thiobarbituric acid, TBA. Okay, and this mixture of distillate and this TBA is heated at 35 degrees, heated in water bath for 35 minutes. For 35 minutes the mixture is heated in a water bath, and the resulting solution, after heating, the resulting solution is then diluted and its absorbance is measured at about 530 nanometer. No doubt this range is in the visible spectrum of the electromagnetic radiation, electromagnetic spectrum. Okay, so that's why all these products are color products. Okay, and these can be identified using spectrophotometric determination or using visible spectrophotometer. Okay, so this is the procedure for getting T bars test, for obtaining T bars test or TBA test. Okay, this method is used for the determination of particularly melanoaldehyde. Okay, and this reaction is done with the TBA, that is thiobarbituric acid. Now the next type of analysis here in lipid sample, conjugated dienes and trienes. Conjugated dienes and trienes. We know that what are dienes? When in a system or in a given compound, if there are double bonds, two double bonds are present. Di means two, in means carbon-carbon double bond. Two double bonds are present. Okay, then they are called as trienes. If there are three double bonds are present, three, then we call them as those compounds are trienes. Okay, now what is the principle of this method? Actually, in oxidation process, in lipid oxidation process, the non-conjugated dienes, these are non-conjugated dienes. Let us see. These are non-conjugated dienes. So the conjugation is not broken here. Okay, so these are non-conjugated dienes. They are converted to conjugated dienes. Okay, upon oxidation. Okay, and hence such fatty acids conjugated diene hydroperoxides, FACD hydroperoxides means fatty acid conjugated diene hydroperoxides absorbs the radiations UV light at 232 nanometer. So at low UV 232 nanometer, the hydroperoxide dienes are absorbing the radiation, and the conjugated trienes are absorbing the UV light at 270 nanometer. So this is the principle of conjugated dienes and trienes. No doubt, as there is a use of UV radiations, means we are going to determine this conjugated diene and triene by spectrophotometrically determination. Okay, now what is the procedure? The procedure is very simple again. Make a 1% solution. Make a 1% solution of the sample, lipid sample. What is by 1% solution? For example, take 1 gram of sample in 100 ml solution. 100 ml solution. So this will give you 1% solution. Okay, or if you take 0.25 gram sample, you have to make a solution up to 25 ml. Okay, so it is also 1% solution. So 1% solution of the lipid sample is then taken and it is diluted with a distilled water or deionized water, and the resulting diluted solution must be clear, and such solution is used for the spectrophotometric determination by using UV visible spectrophotometer. You can measure the absorbance at absorbance with UV spectrophotometer. Okay, so this is a simple method for the determination of conjugated dienes and trienes. All these are products. So this one and this one, all these are utilized to determine the secondary oxidation products of lipid oxidation. Okay, so these are related to the determination of different samples, different components or characterizations of the lipid samples. Application of this conjugated diene and triene is, it is useful in determination of early stages of oxidation. Early stages means this oxidation, when it is start oxidation of this lipid sample when it is started, then at that stage, that is early stage of that sample, these conjugated dienes and trienes may be formed, okay, and hence these are useful in these early stages of oxidation of lipid samples. Okay, so today we have seen the three methods or three analysis types: peroxide value, p-anisidine value and Totox value, T bars and TBA test, and the last one is conjugated diene and conjugated triene. Okay, mind it well, peroxide value is useful for the determination of peroxides and hydroperoxide formed in the oxidation process. Peroxides and hydroperoxides are the first oxidation product of this lipid oxidation or auto oxidation of lipids. Okay, then p-anisidine value and Totox value, they are used to determine the secondary oxidation products such as alpha and beta unsaturated aldehydes with the p-anisidine. Okay, and Totox value is the combination of peroxide value and Totox value. Okay, then third one is the T bars test and TBA test. Okay, so this is the this TBA test is utilized to particularly mainly determination of the melanoaldehyde. Okay, and the last one is conjugated dienes and trienes. These are also secondary oxidation products, and at early stages of oxidation of lipid samples, they can be used by using UV visible spectrophotometry. Okay, so this is the summary of the discussion that we have done today in about the characterization of lipid sample. Okay, thank you for watching this video. Have a nice day. Thank you very much.